Nick Hutchins. Nick Hutchins is away and can't be here, so I'll take his place. Pretty excited to have this session at this fantastic conference on vessel efficiency, something I'm very passionate about. And we've got a great lineup of speakers who have come from all over the world, as many of us have. And first up is Haoliang Chen, who's come from Singapore and is from AkzoNobel. Just get you to talk.
Good morning, everybody. I hope you had a great evening and enjoyed yesterday's session. Yesterday, first of all, before I start my talk, I would like to thank Jason and John for their invitation and support for me to be here. Yesterday, we heard a lot of great talks about the risks of biofouling, and from the biology point of view, regulation point of view, and also from the offshore oil and gas industry. Today, the first session, we are going to look at it from a different angle, from the engineering perspective. So before I start, I come back to the regulation. Yesterday, we talked about the regulation from the national and regional perspective. But I would like to ask a question. In the nearest future, what is the most important regulation at a global level for shipping industry? Anybody can give a shot? I'm talking about the IMO sulfur limit, which will be implemented in 3 months. In fact, less than 3 months, because it will start from the, It will start from the 1st January 2020. And to compliance with this regulation, there are two options. The first is either you choose to burn the low sulfur fuel, or you choose to install the scrubber. Neither of them is not cheap. So very sensitive. Okay, more expensive than me. Neither of them is cheap, because whatever the initial investment or the long-term operational cost will be millions of dollars for individual vessel. So this will urge the ship owner to look more needs, urge their needs to pursue the opportunities to improve their ship efficiency. So that's, and then if we, from the engineering point of view, it will make sense for us to look holistically what will be the potential benefits and of different strategies can be employed to improve the vessel efficiency. Here we take an example from recommended by DNVGL. They are talking about improving the bulbous bow, improve the main engine or auxiliary engine efficiency, also the propeller modification or install the energy saving devices. So depending on the vessel age and the original design of ship efficiency, all the changes in the coming ship operation, like now more and more ships they reduce their speed. So there could be a good reason on some business case to review some or all of these options. But also there are other options which is now become a popular word in the industry. One is air lubrication, and another is flatten the rotor, which means use the wind to power the ship. So of course, all of these options, they are valid and may provide the benefit in terms of the expected efficiency improvement. However, we cannot overestimate we cannot overlook or underestimate some other factors. So I will explain what do we mean. Otherwise, because this factor will negate the potential expected benefit from this improvement. So take one step back. We look at some fundamental. The major resistance when ship is operated as a sea, including the frictional resistance and the wave-making resistance. The relative importance of these two forces depends on the several key factors, like hull form design, like ship size, ship type, vessel speed, and hull and propeller condition. When we talk about the ship efficiency, fundamentally, we are looking at the delivery power and speed relationship. In fact, for one particular ship, once it is built or out of the dock, the ideal speed and power relationship is fixed. It's just over the time, like all vessel ship owners, they know that the speed power curve will degraded because of change of the hull and propeller condition over the time, whatever is the hull damage during the in the pores, or is because of accumulation of biofouling on the surface. So over the time, it means from engineering point, when we talk about the ship efficiency and all the ship efficiency drop, it basically means to maintain the ship, to maintain the same speed, we need more power. Or alternatively, if we constantly output the same power, the speed will drop from the right to the left. This causes speed loss. So this is basically what we are talking about, the ship efficiency. And then when the important thing is when operator is planning for the future, how they can position the requirement to manage the condition of the hull and propeller versus other investment decisions, like mentioned in the last slide. Of course, here I'm talking about the fouling control. Then many vessel operators appreciate the need to control the biofouling by application of efficient fouling control coatings, and also plus the hull and propeller cleaning if needed. The potential range of impact of biofouling growth on vessel efficiency is huge, and from the left to right, in general, the softer biofuel to the hard barnacle will increase the friction resistance. As for the exact number, okay, scientifically, we still can debate and need more research to look at this number. But in general, this provides some hint how the impact can be in terms of we call the power penalty. On the other hand, we should pay attention to that. This may serve just as a general guidance, because depends on nature of the biofouling, depends on extent of fouling growth. This number can significantly change, even for the slime and for the barnacle. So it doesn't mean the fixed penalty. At the same time, put up this thing. In fact, as easily illustrated in the pictures, from the left to the right, more frictional resistance induced by the fouling growth. It also means increase the risk of invasive species. So from that perspective, basically we are consistent in terms of regulation expectation and target, as well as the ship owners' economic incentive. So all have the same goal. We want to maintain a smooth and clean hull. The question is, how do we do that? And then in AkzoNobel, we definitely need to customize our product offers to our customer to fulfill different needs and consider all these complex factors and also the dynamic scenario of this whole time period. So what are the key factors we need to consider when we make the prediction or do the recommendations? These are the list of the key factors. In fact, if you recall yesterday's talks, when we talk about the regulation, implementation, and practice, basically we're talking about similar factors, whatever the ship type, size, operational profile, what coating is used and going to be used, all these are similar. So again, this means from the regulation body point of view and from the industrial player point of view, we have the similar source, and also we can achieve a joint goal. One of the challenge to make best use of these factors is whether we have substantial database. So this is always the first step, because without data, we cannot make sound decision. So luckily, in AkzoNobel, we have decades record based on our in-house data plan system or event report system. In that system, we record more than 250,000 vessel inspection records for the decades. And of course, at the beginning, we didn't foresee we will have this wonderful use. Then this database, we record the coating performance in docking and out docking for the hull condition, corrosion, fouling growth, all this together. And also, we have the surface preparation information. With all this information linked with the hull surface measurement, which was done by hundreds of TSR globally, we can build up the coating performance model of or the hull roughness prediction. And at the same time, if only have this coating performance data, the use is limited if we cannot link with the operational profile. So we have our in-house tool, we call it InterTrack, which powered by the AS data and the environmental database, can help us track the ship route, which is normal for the nowadays. But not only that, we map it with the fouling challenge. For different route, different season, because the ship goes through that particular region and the season, they may face different fouling challenge. So we combine them, and also including the percentage of activity, we can come out with a better prediction model of the surface condition, and also convert it based on the state-of-the-art the research work done by our academia colleagues to come out with a prediction model for the hull roughness. And then this hull roughness, they need to link with the particular trading route. So because we have thousands of trading routes and for the different ships, so in order to simplify the work, we group them to the aggregated routes. Here we take 9 routes. Of course, it's a little, sometimes it's a compromise between whether we take more detailed routes or the less number. And also the coating performance can be linked with this aggregated trading route, and for some routes, definitely it's harder for the coating performance, like the coastal warm water will face a high challenge. And then within this route, within this review, we can develop a coating performance model for specific products, specific trading route, and also because we have in-docking and out-docking and the in-service performance data, we can build up the dynamic development curve for the fouling growth and how roughness change. That's only at the fundamental level. Going forward, moving one level up, because for the owner, we need to predict the powering and the fuel consumption. For this work, based on our prediction of the hull roughness, we work with Marine, which is one of the famous naval architecture consultant and research institute in Netherlands. So they help us run the simulation and to come out with this. Confused with the button now. So, okay. They can help us to predict the power requiring for different speed and different hull roughness level, which means this will be unique dynamic condition for this particular scenario. And combined with this, think about just now, all this recap the picture. We have the fundamental InterTrack system, performance records, and the link with the full-scale CFD model. We can come out with a prediction tool we call InterTrack Vision. This helps us to predict the potential benefits for different scenarios and for different coating selections. Of course, then the natural question is, how do we validate that? Whether we can validate that. So here I take one example. If we take one particular ship, chemical carrier, this is the ship dimension. This is the trading route based on the customer feedback. And this is the expected operational profile, speed, vessel activity, which means the speed is larger than 3 knots most of the time, and 60% of the time. And also the sea miles per month is about 5,000 plus per month. And this is a reference fuel consumption level per day, and also the current fuel cost. Current is, I didn't touch. Okay, so this come out with a prediction for 3 selection products. One is biocide anti-fouling ultra plus premium. What is the predicted percentage, relative percentage in terms of over the whole dry-dock cycle? Then so link with the speed power curve. Over the time, because there are more fouling accumulation on the hull, to different level, definitely they will increase the power requiring. But for different products, they have different performance. That's why, especially towards the end of the dreadnought cycle, the performance is different. And in fact, yesterday I just learned from David's presentation. Also go back to the hotel. I learned his paper. It's wonderful, and it was similar back to 2016. His paper basically mentioned about this good coating performance and the poor coating performance. This is difference the performance. In fact, our first version of Intra Vision was launched towards the end of 2015. It means, as a community, industry, and academia, basically our understanding of this topic is progressed in parallel, and also we can benefit each other. So come up with the numbers. We can look at the relative benefits for different product selections. For the Buff Premium, if we choose as a baseline, then we can see the Buff Ultra and the Ultra Plus give the relative the benefits, and also the environmental benefits in terms of reduce the carbon dioxide emission. Because for the Ultra products, you burn less fuel, so you release less carbon dioxide. Then if we go in one step, then to look at the other options, like during the dreadnought, you can install the different energy-saving devices, PBCF or like methyl duct. For each of them individually, in isolation, they can deliver the different levels, around 5% of the benefit. However, if we make this is only in isolation. If we look at as a whole, especially during the dreadnought decision, because of the very tight dreadnought budget, which is the norm in the current industry for shipping, if you choose to spend a lot of time on a lot of investment on this part, but at the same time, you compromise your choice of the anti-fouling coatings, it going to the lower level, it will, your expected performance delivery may not be achieved. This is one thing. So in that case, we need to balance the dreadnought and investment. At the same time, these energy-saving devices, from the NIS perspective, nine indigenous species, is from that point of view, these energy-saving devices, they cannot deliver that benefit. So they still, to fulfill the regulation requirement, they still need to choose a better products and optimized products to deliver the fouling control requirement. So this is one part. And then we come back to the question, how do we validate? Of course, we need real data and real experience to validate our performance, our prediction. So we choose to do the ship performance analysis. This, in fact, is already a routine work in AkzoNobel. We put it a holistic picture to assess the prediction what's the reality, and also not only in terms of vessel performance analysis, not only the routine analysis following the ISO standard, ISO 19030 standard, or use advanced theoretical or empirical formula methods. We also trying to do one step forward. We work with the University College London to use the machine learning and deep learning, try to do the prediction about the upcoming performance and to help us to make the preventive actions to meet whatever the economic requirement or even the regulation requirement. So then of course, to release our now the manpower in any business organization is tight. To reduce our manual workload, we developed this online vessel performance AI tool, which is powered by the UCL's model. And then in fact, it will just be ready to connect to the customer in the last 2 months. And then this can release our time to focus on more deeper understanding about the hull performance and then the better tools development. So then if as a summary, if I take a holistic view, in terms of whatever the ship owner or the regulation body, what can we do to review and also to manage this biofouling problem. We start from the assessment forecast, and also we need to look at the application side, and also hopefully it's the trend. We need to do the monitoring and the analysis. So in terms of the assessment, we have InterTrack. We can do the link with InterTrack. We can do the future forecasting with InterVision, and then application side, we have the event reporting system to further track record all the historical information. Then for the information, for the monitoring analysis, we have InterTrack Perform linked with other inspect report and how cleaning and maintaining report. All this together, jointly, we can come as a holistic review about the potential risks and the management plan. So this is then as a So as a summary, is like choosing and correctly applying the optimal fouling control coatings can give several benefits, not only the economic benefits, but also the minimize the risk of invasive species. Also, it is very important for us to choose the right coating for the right shape, consider all the dynamic and specific scenarios. And there are many manufacturers to consider and need a lot of database. So this is what we can help to the industry. So at the end, the better prediction and management hull and propeller condition should be a holistic process, and we need to review different pieces of information together. Thank you.